CSEC students, welcome to another live CSEC class. Tonight we're going to be looking at area and scale factor. So this is our topic by topic class, and we're looking at area. But we want to see the relationship between area and the scale factor. And I'll explain a little further on what I mean by scale factor. Before I go into that though, I'm going to remind you of the schedule of our classes. We have 5 live PEP classes per week and 6 live CSEC classes per week. So I want you to look at the schedule and write down the days, the times, and the sessions that we do so you don't miss any of them. Here's the schedule. Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you have your hats? Thank you. Another very important question. Have you ever math problem wrong simply because of one little mistake? I'm sure you have, as thousands of other students. Now in this series we're going to be looking at the common mistake that students make with the topic in CSEC. We're going to look at the common errors, demystify everything, make sure you what you're in this series so that you can avoid making mistakes. So stay tuned. Hello, so I know that most students get problems wrong in mathematics is as a result of one single error or one mistake. Well, this is absolutely true, and we're going to be looking at common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. I'm going to invite my dutiful and faithful and committed and dedicated scholar, Imani, to join me on the screen. And we're going to be working together. Welcome, Imani.
Good night, Miss.
And I'm also going to be sharing the screen so we can have access to the board. All right, so good night to those who are joining us in the chat and those on Facebook, YouTube, wherever in the universe you are. Welcome. We appreciate your company, and we would also appreciate your questions, your comments. When you work your answers, please post them so I can look at them and give you feedback. If you are not understanding something, I would appreciate it if you tell me Not just that you're not understanding, but what exactly is it that you're not understanding? Where did you get lost? Because I think you must understand some aspect of whatever we're doing. If not, it means you'd have to go back from scratch and work your way back up, right? So don't just say, Miss, I don't understand. Say, Miss, I don't understand this particular thing. And I will gladly go over it for you. So let's get started. And scale factor. Mean by area and scale factor. And we're focusing on the square and the rectangle. The last topic by topic class that we did, we found the area of the square, area of the rectangle, bearing in mind that square is just a special type of rectangle. So now we're extending that topic and we're looking at area, but as it relates to scale factor. Now, what do I mean by scale factor? All right, so the scale factor would be how much you're enlarging something by. So if you start with a small object, a small shape, and you enlarge it, the scale factor is how much did you enlarge it by. And we're going to see, we're starting from scratch, and we're going to see how scale factor affects the different areas of the original object and the enlarged objects. We're going to work it out and see. We're not starting with any assumptions. We're not starting even with any formulas or anything like that. I could tell you what it will be, but I want us to start from scratch and discover what it is. So here goes. So we have two squares, a baby square and a mama square, or a daddy square, whichever way you want to look at it. So let's say this tiny square, let's say the length of each side is 4 meters. And we want to, let's say we're extending the length by a scale factor of 2. So let's say we're multiplying the length, just the length, by 2. So in that case, the length of this side here would be 8 meters. So the scale factor is 2. This length is twice that length. So let us see what effect that has on the area of both squares. For the small square, the area is side times side, so that's 4 meters times 4 meters. So that would give us 16 meters square. All right. For the large square, so the area would be 8 meters times 8 meters. And that gives 8864, right?
Yes, miss.
All right, what is the relationship between the 16 and the 64? What can we say about the 16 and the 64? for?
The area of the biggest square, even though the length is 2 times the length of the smaller square, the area is 4 times the area of the smaller square.
Okay, all right. So let's note that the area is 4 times. The area of the larger one is 4 times the area of the small one. All right, so we're bearing that in mind. We're going to come back. We're doing an experiment. So let's say for this small square, we had an area of 10, a length of 10 centimeters. And this one is 30. So what's the scale factor?
Yes, the scale factor is 3.
All right, so the scale factor here is 3. So the area of the small square would be what?
Yes, the area of the small square would be 100 centimeters squared.
So that 10 centimeters times 10 centimeters, which is 100 centimeters square. And the area of would be what?
Miss 900 centimeters squared. Miss, you forgot the squared for the small triangle.
Oh, sorry. Thank you. So it would be 30 centimeters times 30 centimeters. Remember, area of a square is side times side. So that would be 900 centimeters squared. So what can we say about this?
Miss, it's 9 times the area of the small triangle.
All right, so this area, the big one is
9
9,
times.
9 times the area of the small one.
Yes.
Okay, let's do 2 more and see if we have a pattern.
Okay, Miss.
Let's do 2 more. So let's say, all right, so for this area, let's use 5 this time. 5 centimeters. And this length, let's say this length is 20 centimeters. What's the scale factor? What's the scale factor? Can you hear me, Imani?
Sorry, Miss. I didn't realize I was unmuted. I said the scale factor is 4.
Night,
Okay,
Miss.
so the scale factor is 4. Good night, Drayshawn. Welcome. Scale factor 4. And the area of small square,
Miss, the area of the small square is 25 centimeters squared.
so that would be 5 centimeters, 5 centimeters, 25 centimeters square. And the area of the big square,
Miss,
so
that
that
would
would
be
be 20 centimeters
4 centimeters squared.
times 20 centimeters. How much that?
400 centimeters squared.
400 centimeters square. What can we say about the two areas? How to compare them?
Means it's 16 times as big as the small triangle.
All right. Is that a triangle?
Sorry, a square.
All right. We're going to do one more because we want to compare and see if there's a pattern there. Let's say this is one centimeter. And this length is 5 centimeters. What is the scale factor?
If the scale factor is 5 centimeters,
Scale factor is 5, not 5 centimeters. The scale factor is 5.
yes, miss.
So the area of the
Small
small
triangle.
square, Imani,
Sorry, I keep saying
stop
triangle.
calling square them triangle, leave my square them alone. All right. So the area of the small square would be 1 centimeter times 1 centimeter, which is what?
1 centimeter squared.
1 centimeter. Okay.
Yes, miss.
And the big one, so
Miss, the
that
big
will be
one.
5 centimeters times 5 centimeters, which is 25, right? 25 centimeters
Yes,
square.
miss.
How much times bigger? The small one is the big one.
Miss 25 times.
25 times.
Okay, so it's 25 times bigger. All right, so we're going to go back now and compare and see if there's a pattern.
Miss, yes, miss, I see the pattern.
So we have done, yes, so we have done 4 of them. The first one, the scale factor was 2, and the area of the big one was 4 times the area of the small one. In this one, the scale factor is 3, and the area of the big one is 9 times the area of the small one. Scale factor is 4. The area of the big one is 16 times the area of the small one. And here the scale factor is 5. The area of the big one is 25 times the area of the small one. Is there a pattern, and what is the pattern if there is one?
Miss, the pattern is that the scale factor, the area of the bigger square is always the square number for the scale factor.
Okay, so you're saying the area of the bigger square, or the area of the bigger square, is the square of the scale factor times the smaller one. So 25 is 5 squared, 16 is 4 squared, 9 is 3 squared, and 4 is 2 squared. So if you know the length, of the small square, and you know the scale factor, if you know by how much you're multiplying that by to get the length of the big one, can we derive a kind of formula then to say how to know how much bigger the area is? Because I have seen several questions on the paper 1, the multiple choice, CSEC, that ask about scale factor and how much more bigger, how much times bigger one object is than the other. And the assumption, I think the general assumption or the immediate assumption would be that if the scale, if the length is bigger by 2, then the area should be twice as big. I think that's what most persons would assume. Or you're saying, well, if this length is 3 times the other one, the area should be 3 times the other one. But that's not what we're finding. We just did an experiment with 4 different squares, and we found that depending on what the scale factor is, the area to square the scale factor that number of times. So if the length of the is twice as big as twice as long as the small one, the area is 4 times the area of the small one. And we found that if the length of the big one is 5 times the length of the small one, the area is 25 times as big. Now I want to test it for rectangles, other rectangles. I'm going to do 2 tests to see if it's the same pattern. Is it just the square, or does it also work for other types of rectangles? So here is a standard rectangle, and in the rectangle, the length and the width in the standard rectangles, not the square, the length and the width are different, right? So if we have, let's say this length is 10 meters, and let's say the width is 2 meters, if the scale factor is 2, that means this length would become what?
Means 20 meters.
This length would become 20, and the width would become what?
4 meters.
4. All right, so the area of the small one would be what?
Means
10
that would be
meters times
squared.
2 meters, which is what?
20 meters.
20 meters squared.
20 meters squared.
20 meters square, all right.
Yes.
And the area of the big one would be?
8 meters squared.
This was 8 meters squared.
So 20 meters times 4 meters is 80 meters squared. Is it obeying the same pattern? How much times bigger than 20 is 80?
It's obeying the same pattern.
How much times bigger than 20?
4 times bigger.
4 times, right?
Yes, miss.
Which is the square of the scale factor. You see that?
Yes, miss.
All right, so let's try one more just to double check. It seems to be obeying the same pattern. It seems to be obeying the same pattern, but let's double check. All right, so let's say, what did I do? Let's say this is 15 meters, and that is 3 meters, using a scale factor of 4. So if it's a scale factor of 4, then what would this length become now?
It's 60 meters.
Right, because we're multiplying it by 4, right?
Yes, miss.
So it will become 60 meters. And the width would become what?
12 meters.
Because 3 times the 4 would give 12 meters.
Yes, miss.
So let's work out the area. The area for the small rectangle would be 3 meters
Miss, that's 45 meters square.
times 15 meters. Okay, so that's 45 meters squared. And the area of the larger rectangle would be 60 meters
Miss, and that would be
times
720 meters square.
12 meters. How much is that?
720 meters square.
Divide 720 by 45 and tell me what you get.
Miss, you would get 16.
So it's 16 times as big.
16.
Yes, miss.
And 16 is the square of 4,
4.
right?
Okay.
Okay. So we can safely assume then that for rectangles,
It's the same thing.
if we know the scale factor, we can determine how much bigger one rectangle would be than the other by squaring the scale factor. Okay, we can assume that, right? All right. Now I'm gonna ask you to do something. All right. So here we have a square. And the length of the square is 13. Come on. Boy, when these things plan to misbehave. The length of the side is 13 meters. If I am enlarging this square with a scale factor of 6, I want you to work out for me what would be the area of the new square and how much larger would it be?
Miss, what's the question?
Um, so I'm saying I'm enlarging this square with a scale factor of 6. What would be the area of the new square and how much larger than the small square would it be?
Okay, miss. So 13 times 6 is 78, which would be the one side of the square, of the bigger square. So 78 times 78 is 6,084. And to get the difference of the two areas, miss, I subtracted the area of the small square, which is 169, from the 6,084. I don't think I did that correctly. Hold on. I didn't
Go
get
try again. Try again.
this.
So, Drayshawn, did you work it out?
Thinking of what to do for it.
Miss, maybe excuse for a second, please.
Okay.
Thank you.
All right, so Drayshawn, how are you approaching this?
So miss, if the scale factor is 6 on the side of the, so miss, would you do 13 times the scale factor, which is 78, and miss, for the other side, miss, would you do uh, miss, the 78 times, miss, would you do 78 times 13 to find the length of the other side? The
We want to know the area of the large square and how much larger than the smaller square it is.
mm, mm,
Think about it. Um, look back at look back at what we did for that. Well, it's a square. So look back at what we did for that.
Yes, Miss. Okay, I was saying that since the scale factor is 6, I multiplied 13 by 6 and I got 78. But 78 times 78 is 6,084.
So let me write what you're saying. So you're saying the scale factor is 6. So the area of the larger, so the length of the largest, the length of the side of the largest square would be 13 times 6, which is 8,
Yes, Miss.
right?
Yes, Miss.
And the area of that square would be 78 times the
78.
8, which is
6,084.
all right.
Oh, what was I worrying? Wait, no. That's what I was worrying about. Okay, Miss. And then I got the square of 13 since it's side times side, which is 169. Oh, I'm supposed to continue. Sorry. And oh, it's 36 times as big as the smaller square, Miss. I
This
thought I
was
was doing something wrong. No, Miss,
you
600.
squared the 13 and divided it into 6,048.
No, Miss, 6,084.
so miss, is it 6,084, 6,048?
You squared the 14 and divided it by 6,084.
No, Miss, this is what I said. I said when I got the 6,084, I squared the 13 to get the area of the smaller square, Miss.
And then
And then
what?
I divided it. I divided 6,084 by 169 to get the my answer. I thought it was wrong, but I realized it's correct. It's 36
How you
times
realize
as
it's correct?
miss, because 36 is the square of 6, miss, and 6 is the scale factor.
So why didn't you just square the scale factor to begin with? Since we did 6 experiments a while ago, and we determined that if you want to know how much bigger the big one is than the small one, just square the scale factor. So why did you bother to find the area of the small one, divide it into the area? You should just know that, square the scale factor.
Wow.
We just did the experiment, right? So we did what? How many of them? 6 or 7? So we can say definitively, if you want to know how much bigger a big square is than a small square, once you know what the scale factor is, just square the scale factor. That will tell you how much bigger, right?
Oh.
Now, I want you to write this down. I want you to just jot down the points that I'm making. Or rather, let me write it. Let me write it. Okay. So here goes. We're going. I want you to work this out for me. So there is a square. There's a big square, right? The big one.
Yes, miss.
There's a big square and a little square. The area of the big one is 144 meters squared. And the scale factor is 3. What is the area of small square? The area of the largest square is 144 meters square. The scale factor is 3. What is the area of the small square?
Miss, 24 meters squared. Miss, what I did was I'm
Yes,
not.
you
Oh
square
wait,
it.
no, wait, never mind. Go back. Um, 16 meters squared, miss.
Glad you said go back, I'm glad you said go back, girl, because we just do some money for experiment.
Miss, I realized I did something.
Only for experiment is that you were doing wrong.
I actually multiplied the 3 by 2 instead of squaring it. So, okay, so
Oh,
I squared, yes, miss. So I squared the scale factor and got 9, miss, and then divided 144 meters by 9 to get the area of the
all right.
smallest.
But
Very good.
wait, but miss, I didn't get wait. Where the wait?
What did you get?
Oh, miss, I divided it wrong. Wow. What?
Divided
I wrote the
wrong.
wrong thing. Miss, I did 144 divided by 9, but I wrote the wrong thing.
What did you write?
Miss, I wrote 17. I was saying, what is it, 16, and then miss, I
Oh,
just
okay.
went over the division and I realized that it's 16. Oh,
Okay. All right, let's do another one. So again, we have small square, big square. Area of the big square is 196. The scale factor is 2. What is the length of the small square? What's the length of the side of the small square? What's
Miss
the length
7
of the side?
centimeters.
7 centimeters. So tell me how you got 7.
Miss, I found the square number of the scale factor, which is 4, and divided 196 by 4, and I got 49. And since all the sides of the square are the same, the two sides would be the same, and you just have to find the square root of 49.
Okay. All right. So that's 7 centimeters square. Okay. Dreshan, do you understand what Imani just did?
Yes, miss.
All right. So let's do 2 more. All right. So Dreshan, I want you to do this one.
Okay.
And then I'm going to give Imani one to do. Hold on. So we have 3 squares this time. We're pretending that they are squares. Okay, guys?
Yes, miss.
Okay. So let's just use our imagination here. All right. So the what will I give you now? I'll give you the area of the middle square. Let me decide what I'm gonna give you and what I'm not gonna give you. All right. Give me 1 second. All right. So the area of the middle square. This is yours, Dreshan. Area of the middle square is 9 meters square. Right?
Yes,
Okay.
miss.
So the scale factor here is 3. And the scale factor here is, let me see, is 5. All right. So I want you to tell me the area of the smallest and the biggest squares. Imani, you can work it as well.
Okay, miss.
Yes, miss.
Small and big.
So the scale factor from the smallest to the medium is 3. Scale factor from the medium to the large is 5. I want the area
Oh.
of the smallest and the largest.
Oh. Okay, I understand what you're saying. 9 squared. One. This is it. 9. Wait, 3.
Is what 3?
Wait, miss, the area of the small one is, wait, square root of 3 is 9. Oh, yes, miss. This is it. 3. It's 3 meters
Is
squared.
what 3?
But miss the small box.
The area of the small box is 3 meters square,
Yes, miss.
and the area of the largest one is what?
Oh. And that one, convert that one. Oh, it's 5. Yes, 5.
What's the area of the largest one?
Oh.
What do you say, Imani?
Miss, so
What? The
okay, Miss,
this is it.
so on the side of the small of the
This
middle
is it.
box, sorry, would be 3. So 3 times 5 is 15, and 15 times 15 is 225 meters. Meters.
Isn't it
Okay, so you're
15?
saying for the large one is 225,
Yes, miss.
But miss, when you find the square root of
and
that,
small one square root.
this is 225 meters squared.
She's gonna explain how you got the 225, Imani.
It's miss, I know she
Oh,
did,
miss,
but miss, I thought you would find the square root of the 225 meters squared after.
You'd find the square root of what?
Miss, that's not what she did, but miss, I thought miss you'd find the square root of the 225 meters
But
squared.
where the 225 would come from? She just gave me that answer. How would you find the square
I
root
did
of it if you didn't know what it was?
miss, I did 5 squared, which is 25 times the 9. I got 225. Then miss, I'd find the square root.
So how about the smallest one?
miss, it's
What is
not
it?
3 meters.
No?
Miss,
It's
I
not
have
3.
1 meter squared.
Yeah, miss, I got
Okay.
3 and 1, but it said 3.
Miss,
Oh,
I
you had
had
two
1 meter
answers.
squared.
I don't know.
It's one.
Cause miss, for miss first I did 3 squared, which is 9, and then miss I did 9 divided by 9, and then found the square root of that, got 1, but I don't trust that.
So what? It looked weird. You can't
Yeah,
think of an area being 1 meter squared. You can
just
have an area
saying.
that's 1 meter squared. If it's 1 meter for the length, 1 meter for the width, the area is 1 meter squared.
Oh,
All right,
mm,
Imani, here is yours. Again, 3 squares.
Can I use the bathroom, please?
Hurry up and come back. We'll soon finish up. All right, so here we go. Oh my God. No man, them you can't pass a square. I must be able to do better than that. I do believe. I do believe I can do better. Lord help me. Where may I get them square from? No man. Anything when we draw after this have to go, have to stay, okay?
Yes, miss.
Alright. Anything we draw after this is a square. And we're going to roll with it. So that's that. Huh. Alright. And this now. Alright. And then we have one big one. Okay. So what did I give you first? So I gave you the middle one, right?
Yes, miss.
All right. So this time I'm gonna give you the N one. So that's 900 centimeters square. And the scale factor here is 3. And the scale factor here is 5. All right, so fill in the 2 missing areas for me.
Miss, I got my answer. So
So oh, you
this.
get the answer so quick, child. You must give me some time. You do the question breeze off a little bit.
Okay, miss,
What's
I
the
got my.
answer? What you get?
Miss, so since the scale factor for the between the biggest and medium one is 3, the biggest one would be 9 times the middle square. So 900 divided by 9 is 100.
All right. So this is 100. And what you say about the last one,
Miss, the last one, since
or rather
it
the first one?
sorry, the first one,
Mm-hmm.
since the square factor is 5, 100 would be 25 times larger than the small box, which would make it 4. So because 100 divided by 25 is 4 meters squared.
Should you never make the question dry? The ink never dry upon the question yet. You could have made the ink dry upon the question. All right. So when Mr. Dreshan is back. All right, that's it, guys. So you understand scale factor and the relationship between scale factor and area,
Yes,
right?
miss. Yes, miss.
Based on what we've done tonight, I think you understand now. So and we only did the square, the rectangle. When we do area of the triangle, which we were going to do next week, we will also do a section with area of the triangle and scale factor and see same correlation.
Yes,
We're
miss.
going to test, see if you know the scale factor, the length of the triangle, does it have the same relationship between the scale factor and area for the rectangle and the square? We're going to see if that is so. So next week in the topic by topic class, we're going to look at the area of the triangle, and we're looking at three different formulas that we can use to find the area of the triangle. And then we're going to see if the relationship is the same between the area and the scale factor as we discovered for the square. All right, so that's it. Remember, we have our midnight oil class tonight, our CSEC paper 1 multiple choice class from midnight to 2 a.m. We call it our midnight oil class. So be there or be square. I'll see you later, guys.
See you later, man.
Get some rest and be back at 12 midnight.
Bye.
Okay, man. Bye, man.
Later. Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So, stay tuned. Hello, scholars. Did you know that most times when students get problems wrong in mathematics is of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.